Hi everybody, I am going to show you in this video how to calculate the average and the standard deviation of a set of numbers, and also how to properly report those values. So here I have five values, 144 grams, 162 grams, 137 grams, 159 grams, and 164 grams. So we're just pretending that these are five measurements that I took in an experiment, and I want to find the average of these five values, these five masses. And in order to find the average, you need to add all of them up and divide by the total number. So there are 1, 2, 3, 4, 5 of them. In math language, this would look like this. We would sum, so that's the symbol for summing, all of our x values. So each, this would be x1, x2, x3, all the way to xn. And we divide that by n, which in this case is, again, 5. So that would look like 144 plus 162 plus 137 plus 159 plus 164, all divided by 5. Okay, so if we plug that into our calculator, that ends up being 766 divided by 5, which equals 153.2. So that is the average of these five values. Now, some of you might start thinking about sig figs at this point. We will get to that. We are not going to round this to the appropriate number of sig figs until we have calculated our standard deviation. And the standard deviation is basically, where are these numbers changing? How much of a change? So standard deviation is looking at the precision of these values. So you can see 144, 162, 137, 159, these values are not very similar, and they are all changing right here at this digit. So we go from 4, they're all 100 something, but then we have 40, 60, 30, 50, 60. So it's this digit that's changing the most in these values. So our standard deviation hopefully will reflect that. I'm going to show you how to calculate it. So standard deviation is signified with an S, and the equation for your standard deviation is going to be the square root of, again, the sum, but now we're going to sum each of our values minus our average, and then we have to square that subtraction. And we're going to divide all of this by n minus 1. So again, n is 5 because we had 5 values. 1, 2, 3, 4, 5. So n minus 1 would be 4. Okay? So I'm going to go through this whole calculation with you written out. I'm also going to show you how to do this in your calculator. Let me just move this here so we have lots of space. All right, so this equation is going to look like this. So each of these, we have to do this for each of our 5 values. So xn, 144, minus our average, 153.2. So 144 minus 153.2 squared. And we're summing all of these, so again, plus. Then we go to our next one, 162 minus our average, 153.2 squared, plus, and we do this for all 5 of our values, 137 minus 153.2 squared, plus parentheses 159 minus 53.2 squared, and then we still have to add one more down here, but I ran out of board space again. This board is so tiny. 164 minus our average 153.2 squared. All of that is going to be divided by our n minus 1, which is 5, because we have 5 values, minus 1. Then we're going to take the square root of that whole thing. All right, that's a lot to plug into your calculator. So you can do it if you want to just plug in, what's 144 minus 153, that type of thing, and you can go through, and I will actually just write all those down in red above our value. I have it calculated here. So this is negative 9.2. Remember, we have to square it. So the square will get rid of the negative. 162 minus 153.2 equals 8.8. Have to square it. 137 minus 153.2, this is negative 16.2. We'll have to square that. This is 5.8. Don't forget to square it. And this one is 10.8. And again, we have to square it. So to plug all this into our calculator, this is how I would do it. I would say, parentheses, negative 9.2 unparentheses squared. So this little button here, can you see that little x raised to the 2? So when I push that, it squares my value for me. So there's the negative 9.2 squared. Then I'll enter in my 8.8. So plus parentheses 8.8 squared plus negative 16.2 squared plus 5.8 squared plus 10.8 squared. Say equals, that's 574.8. Then we have to divide that by 4, because we're dividing it by 5 minus 1, so divide it by 4. Okay, then we need to take the square root of that number. So on my calculator, it's the same button as the x squared. Well, let me fix that so you can see it. There it is. But it's the little thing above it. So there's our square root symbol. And to get that on my screen, I have to push the second. Then I push this. That gives me the blue square root. Okay, so I'm in square root. But square root of what? And I want the square root of the last thing I had on the screen. So again, I push second, and then I push answer here. So above the negative is the answer that I just had. And then I say equals. And that means we have 11.98749. So that is what our standard deviation equals. So let me write that down on our board here. Give you guys back the full screen. So this equals 11.98749,348. Okay, so far for our values, we have an average of 153.2 and a standard deviation of 11.98749, blah, 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 blah. All right, here is a really, really important rule for this class and chemistry in general. Standard deviations can only be reported to one significant figure. I'm going to say it again because it's so important. Standard deviations can only be reported to one significant figure. So how do we report this number as a value with one significant figure? So it's currently 11.98, and you're thinking that's close to 12, but we just want one sig fig. The only sig fig that matters then is this first guy here. So we say 10. So this equals 10. That is one sig fig. The 0 I know is ambiguous. So you can write it in scientific notation if you want to, but that's going to confuse matters in a little bit, and I'll tell you why. All right, our standard deviation is 10. That means our average value, oops, my computer, there we go. Our average value changes its, what am I trying to say? Its certainty at that tens place. So the 3 is in the ones place, the 5 is in the tens place, and that's what we talked about earlier. Remember, we talked about the values were changing right at the tens place. So this is where our value is really changing. So it makes sense that our standard deviation represents that. So how do we now properly report our average and our standard deviation? And we have to report our average based on our standard deviation. Wherever our standard deviation's significance ends, that's where our average significance ends as well. So this 153 now needs to be rounded to this place here, because we're dropping the 3. We will say it is 1. Whoops. I don't know why I wrote a 5 when I said 1. 150. Okay, so now to properly report this value, we would say the average plus or minus standard deviation of these 5 numbers is 150 plus or minus 10 grams. Okay, so we can put a box around that. Don't forget your units. Don't forget your plus or minus. Make sure that your standard deviation and your average have the same significance. And in this case, it's here. So you would say that this is being reported to 2 sigfigs. The 1 and the 5 are significant. The 0 is not. And our standard deviation tells us that. Okay, so now how do we get this same calculation in our calculator in a much simpler way? I'm going to show you. Let me clear my calculator here. So I know we all have different calculators, so you're going to have to figure this out for your particular calculator if you don't have it. I know our lab has instructions for the TI-36. This is the TI-30. So let me just see if that helps a little bit. I'm trying to make it clear for you guys. There we go. All right, so the first thing we have to do is enter our data. So if you click data here, it says X1. So that is going to be our first data, or a piece of data, so 144 grams. That was our first number. You click the down arrow. Oh, did I do this wrong? X2, Y1. No, I think I'm in the right place. All right. We just want to do the X's. Last time I did it, it was... I said something different. Well, hopefully it'll work. All right, well, I'll have to make a whole new video. So our second value is this. X3 is 137, arrow down twice. 159, arrow down twice, and then 164. So those are our 5 values, sorry. All right, we can get out of here. Nope, clear this. Just 1. Leave it there. That said 1. Arrow down. We don't have a 6th value. Okay, so now we push our stat variable button, this guy, and it says calculating. So n is 5. We had 5 values. X average, 153.2, which is exactly what we calculated for X average. That's our average value, 153.2. And then our standard deviation, 11.98749348, which is exactly what we calculated with our big long equation. So that was way faster, even with my little whoopsie mistakes of figuring out if I was doing it correctly. But you just enter those 5 values in, and you tell it to calculate it, and the calculator does all the work for you. Now, you just have to be careful that you are understanding what the calculator is telling you. And we just want the n, which is 5, the average, x bar, which is 153.2, and s, which is the standard deviation. Now, you will still have to figure out how to report it correctly, the 150 plus or minus 10 in this case. And yeah, so that part's up to you. So let me just go through one more example